I don't often talk about my day job. I run a software company and we make software for hair salons. You know the whole point of sale system and the appointment booking system. And everything is based on web technology. Deployed on desktop using Electron, or on tablets using Capacitor, or just a plain progressive web app. Woo. Yeah. Just look at how happy these people are. Progressive web apps are awesome.
He's a bit skeptical.
Yeah, so I don't often talk about my day job. What I usually do is talk about web Bluetooth and programming Lego cars with JavaScript, fun stuff. And nobody wants to hear a 30-minute talk about the exciting world about hairstyling. But today is an exception. Just for you. No fun stuff today. Just me venting about my day job. So earlier this year, I got an email from Thomas at Google. And he's part of the Chrome team, and he focused on Project Fugu. And that's an effort within Google and Microsoft to make the web more capable, to add new APIs that allow the web to compete with native applications on mobile and on desktop. And our PWA uses quite a lot of Project Fugu APIs, including the APIs responsible for integrating with hardware, like receipt printers, customer displays, cash drawers. And a couple of years ago, that was simply not possible. But it's getting closer and closer thanks to Project Fugu and various hardware APIs and like Web USB and Web HID and Web Serial and more. And his question was, could we make a demo of our product and show off these APIs? And could we do it in 4 weeks? Which sounds like quite a challenge. And it had to be ready in time for Google I/O Connect in Miami. So 2 weeks later, we had a fully running demo. It was completely browser-based, and of course it wasn't 2 weeks' work, it was years in the making. And in fact, I started working on the receipt printer code for my half-stack talk about web Bluetooth back in 2017. And I don't know if somebody was there in 2017. Yes? I don't know if you remember, but that talk failed spectacularly. Nothing about my demos worked. It's just setting up expectations for today. We could scan barcodes and we could add, use barcodes to add products to a receipt. Items are shown on the customer poll, and the receipt is visible on a display. And when we pay, we can print a paper receipt. That was all the functionality that we needed for the demo, and that all worked. So we went to Miami, and that was fantastic. We went to Amsterdam, and Thomas took our demo to Bangalore, and in September, it was shown at I/O Connect in Shanghai. All in all, an amazing experience. So who wants to see it? And afterwards I'll tell you how we created it. And basically, I can use the different APIs like Web HID to connect to a device. In this case, a barcode scanner. And once the device is connected, I can then take a product, scan the product, and it appears on the receipt. Scan some more. And every time I scan something, there's supposed to be something shown here.
Yeah.
And it works. Already works so much better than back in 2017. What happened next? The customer pays, and the cash drawer opens. And when you're done, you get a nice receipt. You get a nice receipt. Anyway, yeah, that is maybe a little bit underwhelming. It isn't flying drones or Lego cars you can drive around. It's just a cash register. And you can scan a product, you can pay, you get a receipt. You can see that every day in every shop or store you go to. But it's actually more complicated than you think. So how did we build it? Like I said, it was years in the making, and I've been playing with this in some way or form, I've been playing with this for the last 10 years. So let's start with receipt printers. So this device is actually a USB device. So we're going to use the web USB API for that. There are actually still serial-based receipt printers or even parallel port receipt printers, but luckily we do not have to deal with those. We're just going to use web USB for this one. And the API allows us to request a device with specific filters. And the user then gets a list of all the devices that they can choose from. The browser then gets access to the device the user chooses. So the web USB doesn't allow any web page just to access all of your USB devices. And once we have the device, we can open it, claim the interface, then transfer out some data to the endpoints. Like, sure. Okay. Maybe some extra explanation. USB devices have one or more interfaces. This usually depends on functionality. For example, if you have a device that combines multiple functions, like a printer-scanner combination, you'll have one interface for the scanner and one interface for the printer part. And each interface has one or more endpoints. And endpoints can be used to send data or receive data, but not at the same time. So in case of a printer, you would have two endpoints, one for sending what you want to print, and one for receiving status information, how many sheets of paper you still have in your printers, the status of the toner, whatever. And we claim the right interface, and we claim it exclusively so that nobody can interfere with us using the device. And then we send the data using trend route to that proper endpoint. Now we know how we can talk to the printer, but we still have no idea what to tell it. We need to learn their language first. So let's start really simple, just 2 lines of text. 1 line in bold. Then we want to cut the receipt. If we were to do this with a web platform, that would be really, really, really simple. Just npm install React, Tailwind, obviously, then have a good think about the build system, and add some divs, of course, because you need divs, and apply a whole bunch of CSS classes, simple. Proper HTML. Just a couple of BR tags and B tags and that's it. But that's not how printers do it. Like we've learned, HTML started simple back in the 1990s, but we're not talking about 1990s technology here. This is more like 70s or 80s technology. The printer language that we're going to use long predates HTML. The very first receipt printer is this. It's an Epson, and it was launched in the 1990s. But it was based on technologies from the 1980s. The MX80 dot matrix printer. And the language is called Escape POS. And it's actually based on Escape P, which the MX80 used. And receipt printers have been using that language ever since. So we need to deal with the language that is based on Escape P from 1980s. But the language is quite simple. It's basically just ASCII. 7-bit ASCII. And with ASCII, we have all the printable characters that you would ever need. 26 of them. A to Z, or A to Z, whatever. And you get numbers as well. And some special characters like $signs. But that's not all. You also have the lowercase versions of A to Z. So, what more do you need? It's the American standards code for information exchange, after all. Now, we have some control characters for data transmission, including line feed, or what we nowadays commonly call a new line. So to print those 2 lines that we talked about, you can just send this to the printer, and it will work. If you send this to the printer, it will print 2 lines. But this is not what we wanted. We wanted the second line to be bold. So let's fix that part. We're not using tags like HTML, but we're using special escape characters that signal to the printer that what follows is a command. So escape E for emphasis, and 1 to turn on emphasis. And that makes the text bold. And escape E0 is to turn it off again. And we have all kinds of commands for formatting, commands for inserting things like barcodes and images, and too many things to list here. Too many things to go into detail. There's the manual. It's about this thick. And we need a command for cutting the paper. In this case, we use GS, and then a V and 0. But we're not done yet. We need to initialize the printer first. Escape at. We forgot to do that, and by initialization, we make sure that the printer is back to its default state, that we don't have any styles from the previous user interfering with what we want to do. But what about these letters? Yeah, we don't have Unicode. Just ASCII, which is fine for the US, but not really for the rest of the world. And even a simple character like the euro is not part of ASCII. I'm sorry, I mean the pound. The pound is not part of ASCII. And even in the US, they have IKEA. So let's go on a tangent and talk about internationalization. And in fact, this could be a whole talk in itself. I could do a whole talk about internationalization. Who wants to do it? No, okay. So this is so complex, we're not going to go into the detail, just scratch the surface. That's okay. Because this is not proper internationalization, it is internationalization before Unicode. In other words, how can we sell computers to the rest of the world with the least amount of effort. So welcome to internationalization before Unicode. How would we print this on our receipt printer? So ASCII is just 7 bits. That means 128 different characters, and we still have another 128 left in a byte. And for that we have code pages. We can swap out a different set of 128 characters in that upper range of ASCII, of the 8-bit byte. It can be Western European, which contains all the characters that we need to use, and which is exactly the reason why you should never use that string internationalization for testing internationalization support. It can be Hebrew, it can be Greek, it can be Ukrainian, which is a different code page from Russian, because Ukrainian uses a number of different characters. Or Thai, there can be many, many code pages. So many, many code pages. So we want code page 858, which contains all the Western European letters. And then we basically start with a Unicode string and we look up the byte value of every character in the code page table. Luckily, there's a library for that. It's called IconV. Unfortunately, it doesn't support all the code pages that we need. It only supports code pages for web pages, not for printers. So I created a library called Code Page Encoder, which is specifically for receipt printers. Of course, not every printer supports every code page. Some support less, some support more, but use a different identifier than what Epson does. And Epson created Escape POS, so why? Why? It is just really annoying. And it isn't just cheap Chinese printers either. Let's talk about something else for a bit. I'm already PTSD. Cache drawers. What about cache drawers? Well, as you can see with this model, it has an integrated cache drawer. So how do we open it? Well, all receipt printers have a DK port, and you connect your cache drawer to that port, and then you can tell the printer to send a pulse to that port. It's basically the same shape as a modem port, except this port will send 24 volts, right? So don't connect the modem to this, if you still have one, that is. But we're talking about 80s technology. So that pulse will tell the solenoid in the cache drawer to open the drawer, and that's it. It's basically not a separate device. It's just an extended function of the receipt printer. And so we're back to receipt printers. When I started this journey, I wish there was somebody that created a JavaScript library just for this. And nowadays you can use ChatGPT, of course, and it will plagiarize my code. But back then you actually had to write it yourself. There were some libraries, mostly server-side, badly written, or JavaScript, but it was based on Node, and not the browser, so I created one. And to get that receipt that we want, we just do this. This is so much easier than everything I mentioned so far, so you can basically forget the first part of this talk. But wait, it can't be that simple? No, of course not. I mentioned that all printers support Escape POS. I lied. Introducing StarPrint, which is exactly the same as escape POS, except everything is different. Great. So instead escape ads to initialize, we now have escape ads can, because we can. Escape T turns into escape GST. And instead of escape emphasis on and off, you now have just escape emphasis to turn it on and escape F to, just escape F for F this. So you have a star printer, then escape POS encoder is completely useless. You need something specifically for StarPrint. So I created a library for StarPrint. Don't use it. I'll get back to that. So receipt printers are a big mess. There were several points during this almost 5-year-long journey that I wanted to give up. There are no standards, and I haven't even talked about the different methods of image encoding, barcode support, the difference between models of the same vendor, printers that support 203 dpi or 180 dpi. How many characters can fit on one line? Well, 44, or 42, or 35, or 32. It depends. It's a big mess. So you remember that picture with all the mobile phones? This is my office. I got more receipt printers than what is considered healthy. and started to mess with me. And every shop that I go to, I try to look for the make and model that they use, because I'm wondering, maybe I should get one more. But back then, back at the bar, they actually have this one. I already have that one, so yeah. So if somebody says to you, you don't need another receipt printer. You already have more than enough receipt printers. Just ignore them. You don't want that kind of negativity in your life. And the result of this madness is a library called Thermal Printer Encoder that supports both escape POS and StarPrint, and it supports all the different resolutions and code page mappings and everything. So if we want to print our original receipt, we just do this and then send the payloads to our printer, and we know how to do that because we talked about it, Web USB. And as a companion to thermal printer encoding, I also created a library that wraps the whole Web USB thing and allows you to simply connect to any supported printer. So no need to worry about endpoints anymore. You can also forget that part of the talk. And there's a set of libraries for even web serial printers and web Bluetooth printers as well, all using the same API. So in our demo, we can actually connect to multiple types of printers using multiple protocols. The code is basically the same. The only difference is I instantiate a different library. So we're done with escape POS. We're done with code pages. We can finally discuss some other devices. Customer displays. So this is basically 2 lines of 20 characters that we can show the current item on the receipt and the total price, so the customer can check if everything is correct. So the important question, do we need another 80s language that we need to learn? What language do customer displays speak? Yeah, they speak printer. And the next question would obviously be, why? And the reason is again found in the 1980s. Because computers back then had only one serial port. Who knows what this does? It allows you to connect 2 devices to 1 port. So they needed to share that port. They needed to work together. They needed to speak the same language. And that's why both speak the same language. So when you initialize the printer or display, both are active, and everything you print is also shown on the display. But you can send escape equals to turn off the printer, or to turn off the display. And it will ignore all the data that you send until you initialize it again. So they need to speak the same language. So web serial, we request a port. We open the port with the right speed, 10 gigabytes per second. No, 9,600 bits per second, because 1980s. And we got our writable stream for sending data to the device, and then we write our payload to the stream, effectively sending it to the display. This is all you need to send data to one of those displays. And that's it. Yeah, we still have to deal with code pages and still to deal with escape POS, but yeah, this isn't right. Our display is connected using USB. Why is it using web serial and not web USB? Because of the 1980s. So let's take a look at USB classes. USB defines a number of default classes, and if you have a device that uses one of these default classes, like video or storage or HID, you don't need to install a driver, it will just work. One of these default classes is CDC for communication, which includes ACM, which is a modern replacement for the old legacy serial port. Now, to use the ACM class or a legacy serial class, you would use web serial. USB is only for custom devices, like that picture all the way over there. If you want to use ADC, for example, you use web audio. If you want to use HID, you'll use web HID. Web USB is only for custom devices. But ACM is a replacement and not backwards compatible. So USB devices or the serial port dongles don't use ACM. In fact, most USB serial devices don't use ACM. Nobody uses ACM. They basically just took their 1980s device, didn't change one bit, added one custom USB chip from FTDI or Prolific, and use a custom driver, and it creates a virtual serial port. And also for virtual serial ports, you need web serial. Now, you could write a web USB driver for these USB dongles. They are custom devices. In theory, you could write. There's no documentation. You would have to reverse engineer it. It's completely useless because you have web serial. It's a big waste of your time. In theory, yeah, don't use it. So in conclusion, nobody actually uses legacy serial ports anymore, but for some connected USB devices, you still need to use web serial. And there's a library for that again. It uses web serial to connect to the display. It will handle all the encoding for you, all the code pages for you. It just works. And that brings us to barcode scanners. And that is really easy. We don't need to do anything to support barcode scanners. Because barcode scanners are just keyboards. So when you scan a barcode, you just literally type out all the numbers. And you could use keyboard events. And of course, you need to figure out where the barcode starts and where it ends, and that can be solved. It's not perfect, but it's good enough. Next. Oh, but a barcode scanner is also a HID device. So we could use web HID to get the actual barcode instead of just guessing where it starts. We request a device again, and then the user selects the barcode scanner. And we get back a list of devices, because most HID devices are composite devices. So there's the barcode scanner part of the device, and there's the keyboard part of the device. We don't get access to the keyboard part, because that would be a security nightmare. But we can get access to the scanner part of the device. And then we need to turn off keyboard emulation and tell it to use plain HID reports instead. And then we listen for those reports. What we get back every time a barcode is scanned is some data, which we can interpret and parse and extract the value of the barcode. Again, there's a library for that. There's a serial version of the library as well. And that was our final device. Still think that demo was underwhelming? Yeah, the demo made it look easy, and that's great. It's supposed to be easy for the user, but it was a huge effort to get this working. And we've always used web technology on our app, but integrating point-of-sale devices was always a struggle. And we needed wrappers like Electron or something, Adobe Air. That's a whole other nightmare. But now all the puzzle pieces are there, they're in place, and we can use progressive web apps. And that's what I love about Project Fugu. It allows us to do things that weren't possible on the web before. It allows us a future of our app without Electron. Nothing bad about Electron, but I love progressive web apps. And it's not just about cash registers or hardware even. It's about all kinds of APIs to make the web more capable. And for us, it really worked. It might work for you as well. And if you do want to use a receipt printer, just use the library. It's so much easier. So thank you.